All right, let's take a look at the practice test. For the instructions, we're asked to sketch the graph of each. All right, let's take a look at the first problem. So we're given f of x equals x squared plus 12x plus 35. So if you're asked to sketch the graph of a parabola, typically you're either going to use graphing transformations or you're going to use that step pattern. So we talked about both of those in the lesson. So it's really up to you which one you want to choose. I think the step pattern is usually faster. It's not always the case, but usually it's going to be the better choice. So for the first one, I'm just going to do it both ways, and then I'll just kind of alternate based on the problem. So the first thing you would want to do for either scenario, you would want to write this in vertex form. So that is f of x is equal to a times the quantity x minus h squared, and then plus k. Okay, let me put a little border here. So you need to figure out what is a, what is h, and what is k. So we know that a is just the coefficient for x squared. In this case, it's understood to be 1. You can put a visible 1 there just for clarity. So a equals 1. Your b, which is something you're going to need, that's the coefficient for x to the first power. So here that is 12. And then you need h and you need k. So this comes from the vertex formula that we talked about in the last section. So h is the negative of b over 2a. So b here is going to be 12. And a here is going to be 1. You can just erase it. So negative 12 over 2, that is negative 6. Okay, so h here is negative 6. What is k? K is f of h. In this case, h is negative 6. And all you have to do is plug in here. So f of negative 6 is equal to negative 6, make sure to wrap that in parentheses, squared, and then plus 12 times negative 6, and then plus 35. We know that negative 6, again, if it's wrapped squared, that's going to be positive 36. So this would be equal to 36, and then plus 12 times negative 6, that's going to be negative 72, and then you have plus 35. So 36 plus negative 72, or you could say 36 minus 72, that's going to be negative 36, and then you have plus 35, and of course, negative 36 plus 35, that's negative 1. So k here would be equal to negative 1. All you have to do once you have this information is just plug in. So a is 1. You could put it there if you want, or just erase it. You don't really need it. H is going to be negative 6, so be very careful with how you write this. This is x minus your h. Again, h is negative 6, so we'll write it like this. So x minus a negative 6, this is quantity squared, and then plus your k. K is negative 1. So in this form right here, you can just say that the vertex is going to occur at h comma k. So h is negative 6, and then comma k is negative 1. So let me actually change the form over. We know that x minus a negative 6 would be x plus 6. So this is x plus 6. Again, then this is quantity squared. And then plus negative 1, you could just write this as minus 1. So this is how I would write it. You just have to understand that if you want to grab the x coordinate for the vertex, this has to be in the form of x minus some number. So you have to change this back over to x minus a negative 6. So that quantity squared. Okay, so let's look at graphing transformations first. You would compare this to the squaring function. We're already using f of x here, so let's just say g of x is equal to x squared. So compared to this, what's happening here? Again, on the inside, you have to undo things. You have plus 6, so to undo that, you need to subtract away 6. So that's going to give me a shift to the left by 6 units. So we're going to say that we're going to shift left by 6 units. Then second, we have this minus 1 on the outside. That's just going to shift me down by 1 unit. So shift down by 1 unit. What I would do to make some points in order to sketch the graph, just follow this right here. So in other words, on your g of x is equal to x squared, you have some x comma y, and that's going to go to when you have f of x is equal to the quantity x plus 6 squared minus 1, where you're going to do what to x? You're going to shift left by 6 units, so that's x minus 6. You're going to do what to y? You're shifting down by 1 unit, so that's y minus 1. So hopefully you know the points on g of x equals x squared. It's something we've worked with a lot. So you could say something like 0, 0. So that's the vertex here. When we go over here, it's going to be 0 minus 6, which is negative 6, comma 0 minus 1, which is negative 1. So negative 6, comma negative 1 would be your vertex, which we found earlier. Then if you take something like negative 1, comma 1, that is going to be negative 1 minus 6, that's negative 7, and then comma 1 minus 1, that would be 0. Then you have something like 1, comma 1, that's going to go to, you have 1 minus 6, which is negative 5, and then comma, again, 1 minus 1 would be 0. Then let's take negative 2, comma 4, that's going to go to negative 2 minus 6, that's negative 8. And then comma, You have 4 minus 1, that is 3. Let's just do one more. So 2 comma 4, this is going to go to, you have 2 minus 6, that's negative 4. And then 4 minus 1, that's going to be 3. So again, this is one way you could do it. Typically 5 points is enough to graph a parabola. Okay, so let me come down here and paste this in. So this is going to be our graph. So we have negative 6 comma negative 1, that's your vertex. Then you have negative 7 comma 0, so that's going to be right there. You have negative 5 comma 0, so that's going to be right there. You have negative 8 comma 3, so that's going to be right there. And then you have negative 4 comma 3, so that's going to be right there. So let me get rid of this, and we can label this. So we could say that this is going to be the graph for f of x is equal to the quantity x plus 6 squared minus 1. Now you can get additional points going if you want. Again, if you had taken something like negative 3 comma 9, and again, you take the negative 3 and you subtract away 6, that's going to put you at negative 9. If you take the positive 9 and you subtract away 1, that's going to give you 8. So if you go 9 units to the left and 8 units up, that's going to put you right there. So that would be another point. Let me label it right here on the inside. So negative 9 comma 8. And of course, you're going to have this point right here, which is going to be negative 3 comma 8. And that's going to come from 3 comma 9. Again, you're taking the x coordinate, you're subtracting away 6. 3 minus 6 would be negative 3. And then that 9, that y coordinate, you're subtracting away 1. 9 minus 1 is 8. So that's how you get the negative 3 comma 8. So again, you can use graphing transformation to do this. This is one approach. Now, the other way would be to use the step pattern. That's pretty straightforward. Typically, that's the faster way to do this. So you still need this guy in vertex form. That way you can get the vertex. That's your first point. And then from there, you're using that pattern. So it's 1, comma 3, comma 5. Let me make the 5 better. Comma 7. And this continues forever. You typically just use the 1 and the 3. Sometimes you use the 5. But essentially, starting from the vertex, you're always going to move 1 unit to the right, and then you go up by the next number in the pattern. So right here, you're going 1 unit to the right. So the x value would now be negative 5, and you're going 1 unit up, so the y value is 0. Again, I'm using that. Then once I've used this one, now I'm going, let me just mark this out as I go. Now I'm going to the 3. So I'm always going to go 1 unit to the right. 1 unit to the right, so now the x value is negative 4, and then I'm going 3 units up. So 1, 2, 3. So if you look, now the y coordinate is going to be 3. Now you can mark this one out. So now I'm going to go 1 unit to the right and 5 units up. That's the next number right there. So 1 unit to the right, now the x value is negative 3, and then 1, 2, 3, 4, 5. So the y value is now 8. So again, now you can mark that out and you would go to 1 unit to the right, 7 units up if you wanted to do that. This is the pattern that you would use. Let me erase this real quick. If you want to do it that way, to get these points over here, remember that your parabola is symmetric with respect to the axis of symmetry. Again, some books call that the axis of the parabola, and that's going to be the line x equals negative 6. So it's always x equals h. H in this case is the x coordinate for the vertex. Let me go ahead and sketch that in. So this is your x is equal to negative 6. Again, that's your axis of symmetry. So what happens is if you look at, so this right here, just look at the x, don't look at the y because the y is going to be the same. How far do I have to go horizontally to get from right here to right here? Well, it's 1, 2, 3 units. In other words, right here, the x value is negative 6. Again, because we're on the line, x equals negative 6. So here, the x value is negative 3. So I had to travel 3 units to the right to get over here to an x value of negative 3. Well, on the other side, again, I have to travel 3 units, but in the opposite direction. So 1, 2, 3 units to the left. So now the x coordinate would be negative 9. The y coordinate of 8 would be the same. So it would be the same thought process here. So if you look at this, I would go 1, 2 units to the right to go here. So I need to go 1, 2 units to the left to go here. This one is 1 unit to the right. So here we go 1 unit to the left. So that's how you get those points over there. So the step pattern is another way to do it. A lot of times that's going to be a lot quicker. But if you want to use graphing transformations, that's another solid approach. All right, let's take a look at problem 2. Here we have f of x equals x squared minus 6x plus 8. Let's first start with the vertex form. So f of x equals a times the quantity x minus h squared plus k. Let's put a border here. So we have a is equal to, the coefficient for x squared is just a 1. Again, you can write that in if you want. Let's put a 1 there. B is equal to the coefficient for x to the first power. That is negative 6. H is equal to negative b over 2a. Well, here's where you have to be very, very careful. You are plugging in a negative here for b, and you have a negative out in front. I'm just going to highlight this. A lot of times I'll wrap this with parentheses, and I'm going to replace this with a negative 6. Then 2a. Well, a is 1, so you can just erase this. So this would be negative 6 over 2, that's negative 3. So this becomes the negative of negative 3, which of course is positive 3. So let's put a 3 right here. And then k is going to be f of h. H is 3, so this is f of 3. So we're just going to plug in here. So we're going to say f of 3 is equal to, you would have 3 squared minus 6 times 3, and then plus 8. Well, 3 squared is 9, and then minus 6 times 3 is 18, and then plus 8. 9 minus 18 is negative 9, so this is negative 9 plus 8, and negative 9 plus 8 is negative 1. So k here is negative 1. And you can erase a. You could put a 1 there if you want, but it's just not necessary. For h, that's going to be a 3, and then for k, that's going to be negative 1, so let's just write minus 1. So let's just do the step pattern on this one. It's pretty straightforward. We're just going to say that the vertex is going to occur, again, at h comma k, so that is 3 comma negative 1, and then from there, you could just use your pattern. So let me go ahead and grab this. Let me paste this in. Let me go ahead and label this real quick. So this is f of x is equal to, you have the quantity x minus 3 squared, and then minus 1. Now, when we look at the vertex, that's 3 comma negative 1, so that's right there. So that would give you that point. The additional points, again, you use that pattern. So it's 1 comma 3 comma 5 comma 7. Now, when I go 1 unit to the right, the x value is now going to be 4, and then I go 1 unit up, the y value is going to be 0. Again, once you use it, you can just mark it out. Then from there, I'm going 1 unit to the right, so the x value is now 5, and then 3 units up, so 1, 2, 3, the y value is now 3. So I would mark that out. My personal opinion is 5 points is enough to get a parabola, so you would get these other two, and I'll do that with the axis of symmetry in a moment. But if you want to do this one, you can. So 1 more unit to the right, so that's going to give me an x value of 6, and then we're going to go up by 5. So 1, 2, 3, 4, 5. That's going to be right there. Probably should use a different color for that. So let's put that like that. So the y value there would be 8. So maybe I'll change this labeling and put it like that. So I can put this point right here, which would be 6 comma 8. So 6 comma 8. If you want these points over here, again, you can use the axis of symmetry. So that's going to be x equals 3. So this is x equals 3. That's your axis of symmetry. And just like we talked about in the last problem, if you're starting with, let's say, this point right here, well, if you're on this line, your x value is going to be 3. So I'm going 1 unit to the right here to get to an x value of 4. So to reflect, I want to go 1 unit to the left over here. So that would give me an x value of 2. So that's how I get 2 comma 0. Similarly, right here, I'm going 1, 2 units to the right. So to get this point, I'm going to go 1, 2 units to the left. And then right here, I need to go 1, 2, 3 units to the right. So I need to go 1, 2, 3 units to the left. So that would give me that point right there, which is 0 comma 8. All right, let's take a look at problem 3. So we have f of x equals 2x squared minus 32x plus 126. So for this one, because the coefficient of x squared is not 1, I'll just do it both ways. I'll use graphing transformations, and then I'll do the step pattern. You have to make a modification when the coefficient of x squared is not 1 to your step pattern. So we'll talk about that in this problem. So here we have f of x is equal to a times the quantity x minus h squared, and then plus k. Let me put a little border here and put that a is equal to, again, the coefficient for x squared, so that's 2. B is equal to the coefficient for x to the first power, so that's negative 32. H is equal to the negative of b over 2a. Well, b is negative 32, so be very, very careful. Let me go ahead and highlight this so we don't make a sign mistake. So this is negative 32 that I'm plugging in there. And then 2 times a is 2. So 2 times 2 is 4. Well, what is negative 32 over 4? That's negative 8. So this would give me the negative of negative 8, which is 8. So let me get rid of this, and let me put an 8 there. K is equal to what? Again, f of h is 8, so f of 8. So f of 8 would be equal to 2 times. You have 8 squared minus 32 times 8, and then plus 126. Definitely one I would just use a calculator for, but let's just go through this. So 8 squared is 64, and then you could do 64 times 2, that's 128. And then you have minus 32 times 8, that's going to be 256, and then plus 126. So 128 minus 256, that's negative 128, and then plus 126. So negative 128 plus 126, that is negative 2. So k is equal to negative 2. So we're going to say that a is 2. We're going to say that h is 8. And then we're going to say that k is negative 2. So you can write minus 2 there, or plus negative 2, whatever you want to do. So we know that the vertex is going to occur at h comma k. So h is 8, and then k is negative 2. So we're going to use the step pattern in a moment. Let me go ahead and grab this real quick. And let me come to the graph, and I'm just going to drop this off right here. So the vertex is at 8, -2. But we're going to go back up, and we're going to do this with graphing transformations. Let me get rid of this. So let's say that you have over here, your g of x is equal to x squared. And again, you'd have stuff like, let's say 0, 0. You would have -1, 1. You'd have 1, 1, and you'd have -2, 4. And then you'd have 2, 4. So we know these points already. You realize that you have, on the inside here, x minus 8. So to undo that, you want to add 8. Always on the inside, you need to undo things. So the first thing is I'm going to have a shift right by 8 units. The second thing is I'm going to do my vertical stuff, and I'm going to do that in the correct order. Remember, vertical follows the order of operations. So you want to multiply by 2 first, then subtract away 2 second. So in other words, I want to do the vertical stretch by a factor of 2, followed by my shift. Let me make this better. So down by 2 units. So this is going to be for g of x. What's going to happen is this is going to go to, well, in terms of x, you're shifting right by 8 units, so x plus 8. In terms of y, you're multiplying by 2 first, so 2y, and then you're subtracting away 2 seconds, so minus 2. So this right here, 0 plus 8 would be 8, and then 2 times 0 is 0, and then 0 minus 2 is -2. We already know the vertex occurs at 8, -2. This is the vertex here for g of x equals x squared. This is the vertex here. When we go to f of x equals 2 times the quantity x minus 8 squared, and then minus 2. So then going here, you would have -1 plus 8. That's going to be positive 7. And then 2 times 1 is still 2, and then minus 2 is 0. Now this y coordinate here would be the same. The x value is going to change. 1 plus 8 is 9. So now you have 9, 0. And then for this one, you have -2 plus 8. That's going to be 6. And then you have 2 times 4, that's 8, minus 2, that's going to be 6. Again, for this one, the y coordinate is going to be the same. For the x value, 2 plus 8, that's going to be 10. So again, this is one way you could do it. Let me go ahead and grab this real quick. Come back down here and paste this in. So again, you have your vertex, which is at 8, -2. Then you have a point here, which is 7, 0, a point here, which is 9, 0, a point here, which is 6, 6, and a point here, which is 10, 6. So one way to do it. The other way, again, let me go ahead and label this. So this right here is f of x is equal to 2 times the quantity x minus 8 squared, and then minus 2. Another way to do it is to use that step pattern. But this is the tricky part here. Normally it's 1, 3, 5, 7, so on and so forth. But that's when the coefficient for x squared, or the a value, in this case it's this number out in front of these parentheses here, that's when that's 1. If it's not 1, you have to multiply each number in this pattern by whatever a is. So the pattern here would be 1 times 2, which is 2, and then 3 times 2, which is 6, and then 5 times 2, which is 10, and then 7 times 2, which is 14, so on and so forth. So this is the pattern that you want to use. This is very important to understand, and if you don't make that modification, you will get the wrong graph. So be very, very careful if you're using the step pattern, and the coefficient of x squared is not 1. So starting at the vertex 8, -2, again, I can go 1 unit to the right, and now, because this is a 2, I've got to go 2 units up. So 1, 2. So the x value goes from 8 to 9, and the y value goes from -2 to 0. So that gives me the point 9, 0. So I'm going to mark that out. The next number right here is a 6. So 1 unit to the right, 1, 2, 3, 4, 5, 6 units up. So the x value of 9 goes to an x value of 10, just going 1 unit to the right. And then the y value of 0 goes to a y value of 6. Again, I'm going 6 units up. So that's the 10, 6. So you can mark that out. Again, if you were going to continue here, which it doesn't have room on this graph, but if you were on Desmos or something like that, you could just go 1 unit to the right and then 10 units up. So that point would be 10 plus 1 is 11, and then 6 plus 10 is 16. So if you're on Desmos, and I gave you a link for that, you can check that 11, 16 is going to be on the graph, and I promise you it will be. Now, in terms of these guys over here, again, you're going to use this axis of symmetry. So x equals 8. If I'm right here, again, the x value is 8. Well, to go right here, I need to go 1 unit to the right. That gives me an x value of 9. Well, when I go over here, I need to go 1 unit to the left. So now I have an x value of 7. The y value is still the same as 0. Same thing over here. If I need to go 1, 2 units to the right here, I need to go 1, 2 units to the left here, so on and so forth. So just be very, very careful if you're sketching the graph using the step pattern and the coefficient for x squared, the a value is not 1. All right, for problem 4, we have f of x equals negative 2x squared plus 16x minus 29. So for this one, I'll just use the step pattern. So what we'll do here is just write this in vertex form. So f of x is equal to a times the quantity x minus h squared, and then plus k. So a is equal to negative 2. B is equal to positive 16. Then your h is equal to the negative of b over 2a. Well, b here is 16. A here is negative 2. So 2 times negative 2 is negative 4. So this is the negative of 16 over negative 4, which is negative 4. And so the negative of negative 4 is 4. So h here is going to be 4. Then your k is equal to f of h, so f of 4. So let's say that we have f of 4 here. So this is equal to negative 2 times. You would have positive 4 squared plus 16 times 4, and then minus 29. 4 squared is 16. Negative 2 times 16 is negative 32. Then plus 16 times 4 is 64, then minus 29. Negative 32 plus 64 is 32, and then 32 minus 29, that's going to be 3. So let's come over here and erase this and put that k is equal to 3. Let's erase the a and put a negative 2. Let's erase the h and put a positive 4. Let's erase the k and put a 3. So here we would have the vertex. So the vertex would occur at, again, h comma k, so that is 4 comma 3. And let me come down here and paste this in. So I'm just going to label this real quick. So this is the graph for f of x equals negative 2 times the quantity x minus 4 squared plus 3. The vertex occurs at 4 comma 3. So that's going to be up here. So that is the highest point on this because it's downward facing. When you use the step pattern here, you have to be very careful because the a value is negative. Remember, if it's a negative a value, this guy is downward facing. So your pattern, which is, again, normally 1, 3, 5, 7, continuing forever, well, now you're multiplying each one of these guys by negative 2. So you're going to get 1 times negative 2, that's negative 2. 3 times negative 2, that's negative 6. 5 times negative 2, that's negative 10. And you can just stop there. So on and so forth. You could do 7 times negative 2, that's negative 14. But again, it's not necessary. You're not going to use that. So this is the pattern that you're going to use here. Again, if the coefficient for x squared, that a value is not 1, you have to make this modification. We're starting at 4 comma 3. We're going to go 1 unit to the right. So the x value is now 5. The number in the pattern here is negative 2. So that means I'm going to now drop by 2. 1, 2. So the x value went from 4 to 5. I increased by 1. The y value went from 3 to 1. So it decreased by 2. So that gives me the 0.5 comma 1. Then we're going to the next number in the pattern. So get rid of this. Now we have negative 6. 1 unit to the right. So the x value is 6. And I'm going 6 units down. So 1, 2, 3, 4, 5, 6. So the y value is now negative 5. Again, the x value went from 5 to 6, so we increased by 1. The y value went from 1 to negative 5, so we decreased by 6. So then you would mark this out, and you can go to negative 10 next. So again, this is not on this graph right here because there's no room, but if you go to the link on Desmos, you'll see that you can go 1 unit to the right, so that would be 7, and then you would go 10 units down, so that would be negative 15. So you can check that on Desmos. You will see that 7 comma negative 15 will be on the graph. Again, I have a link for you if you just want to click it. All right, so in terms of the points over here, again, you can just reflect across the axis of symmetry. Okay, so this is x is equal to 4. So if I just wanted to start, let's say right here where the x value is 4, to travel over here to this 0.5 comma 1, I need to go 1 unit to the right. So to get this point over here, on the other side, I need to go 1 unit to the left. So now I would have 3 comma 1. Then coming down here, it's the same thought process. This is 1, 2 units to the right. So to get this point over here, I go 1, 2 units to the left. All right, for problem 5, we're given f of x equals 1/2 x squared plus 4x plus 7. All right, let me slide down here a little bit. So one thing to understand is that if the coefficient for x squared is not an integer, so in this case you have 1/2, well, it's going to be much more tedious when you consider using the step pattern. So you might want to use graphing transformations. So for this one, I'll just do it both ways just so you can compare. So let's go ahead and say that we have f of x equals a times the quantity x minus h squared, and then plus k. Let me make this better here. Let me put this like that. So a here is equal to, again, the coefficient for x squared, that's 1/2. B here is equal to the coefficient for x to the first power, so that's 4. H is equal to the negative of b over 2a. A? Well, if we look at B, that's going to be 4. And if we look at A, that's going to be 1/2. 2 times a half is going to be 1. So this turns into -4/1, which is just -4. In terms of your K, this is equal to f of h, so f of -4. So you have f of -4. This is equal to 1/2 times -4 squared plus 4 times -4, and then plus 7. So -4 squared, again, this is wrapped here. That would be positive 16. And then 16 times a half, that would be 8. So then 4 times -4, that would be -16. So let's go minus 16 and then plus 7. Well, 8 minus 16 is -8, and then plus 7. -8 plus 7, that's -1. So K here is -1. So let me just write this out. So f of x is equal to 1/2 times the quantity, again, x minus a -4. We'll change this over in a moment to x plus 4. So this is quantity squared. And then you have plus -1, you can just write -1. So what you would say is that your vertex is going to occur at h comma k, so -4 comma -1. And I'm just going to paste this right here. We're going to come down to this in a moment. You can already see that -4 comma -1, that's the vertex. But let me come back up and let me change this over into x plus 4. And actually, I'm just going to rewrite this. So f of x equals 1/2 times the quantity x plus 4, quantity squared, and then -1. Okay, let me get rid of this. Now, if you're going to use graphing transformations, again, comparing this to g of x is equal to x squared, well, again, you have on the inside, you want to undo what's being done to x. Well, I have x plus 4, so I need to subtract away 4 to undo that. So the first thing is we're going to shift left by 4 units. Second thing, again, now we're dealing with the vertical. When you deal with vertical, again, you're going to follow the order of operations. So the multiplication by 1/2 is done first, followed by subtracting away 1. What happens when you multiply by 1/2? Again, you could say there's a vertical compression by a factor of 2, or you could say there's a vertical shrink by a factor of 1/2. Again, different terminology, same meaning. So I'm just going to say that there's a vertical compression by a factor of 2. So that means you can take the y value and divide it by 2 or multiply by 1/2, whatever you want to do. Then the third thing is we're going to shift down by, let me make this better, 1 unit. So that's coming from the -1 there. So if you have some x comma y, that's from g of x equals x squared, that's going to go to, well, for the x, you're just shifting left by 4 units. So that's x minus 4. For the y, there's a vertical compression by a factor of 2. So that's y over 2. And then you're shifting down by 1 unit. So then -1. So let me go ahead and grab this and come down here. We know what the vertex is. Let me just erase this. I'm going to paste this in right there. Come back and paste this in here. So we have a little labeling going. So I'm just going to arrow to that. So let's just start with some points that we know. Again, if you have something like 0, 0, what is that going to go to? Well, 0 minus 4 is -4. And then 0 over 2 would be 0. And then -1 would be -1. Again, 0, 0, which is the vertex on g of x equals x squared, is going to go to -4, -1. Again, we already found that that was the vertex, and we can see that clearly there. Now, here's where things get a little bit tricky. Normally, we use -1, 1 and 1, 1, but because of this dividing by 2 here, you're going to get a non-integer value. Now, you can still do it. So -1, 1, if you go -1 minus 4, that's -5. And then y would be 1 here. So 1 over 2 is 1/2. And 1/2 minus 1, you can go 1/2 minus 2 over 2. That's going to be -1/2. So -1/2. And then for this one, if you have 1 minus 4, that's -3. And then again, you would have this -1/2 for the y value. I don't have that done here, but if you look, if you go to -5, -1/2, that would be right there. So that would be that point. Again, it's not an integer for the y value, so it's something I typically would not do, but we can label that real quick and say that this would be -5, -1/2. And then this guy over here, let's see if we can line this up. So this is -3, so this would be -3, -1/2, if you want to use that as a point. So in this case, let me just erase this. Again, you can click that link on Desmos if you want to go over something like that. I would go to the next guy that's going to produce an integer. So let's use -2, 4, and then 2, 4. So -2, minus 4, that's going to be negative 6. So that's the x value here. And then plug in a 4 here. 4 over 2 is 2. And then 2 minus 1, that's going to be 1. So negative 6 comma 1. So you can see that point right there. And then this one right here would go to, you have 2 minus 4, that's going to be negative 2. And then you have 4 over 2, again, that's 2. And then minus 1, that's again 1. So that's your negative 2 comma 1. Now when you go to the next ones, again, you're going to have a similar issue. So if you went to negative 3 comma 9, and you went to 3 comma 9, you're going to get stuff for y that's not an integer. So if you want to avoid that, again, you can just go to the next one, which is negative 4 comma 16, and then 4 comma 16. And so this one right here, negative 4 minus 4, that's negative 8. And then if you do 16 divided by 2, that's 8. And then 8 minus 1, that's 7. So that's your negative 8 comma 7. And then this one right here, 4 minus 4 is 0. So it would be 0. And then again, 16 over 2 is 8, 8 minus 1 is 7. So that's where you get the 0 comma 7. So just some things to consider if you don't have an integer for your a value. So something like 1/2. If you're using the step pattern, let me get rid of this. Again, we already know that the vertex occurs at negative 4 comma negative 1. I don't need to rewrite that. Again, it's normally 1 comma 3 comma 5 comma 7, so on and so forth. You need to multiply this by positive 1/2. 1 times a half, which is a half. Then you get a half times 3, which is 3 halves. Then you get 5 times a half, which is 5 halves, and you get 7 times a half, which is 7 halves. This might not be so easy to work with. If you start right here, you're basically going to have to go 1 unit to the right, so the x value is negative 3, and then a half a unit up. So we're back to that point that we found earlier, which let's just say that's right there. That would be your negative 3, comma, and then you'd have negative 1/2. Because essentially you're taking the y value, which is negative 1, you're adding 1/2, so that puts me at negative 1/2. Then again, you go 1 unit to the right, so now the x value is negative 2, and you're going to go, the next thing is 3 halves units up. Well, negative 1/2 plus 3 halves, that's going to put me at 1. So now I get negative 2 comma 1. So I would probably avoid this and just use graphing transformations for this one, although you can do it if you want. If you wanted to continue, let's say you go 1 unit to the right, so now the x value is negative 1. Now the next number here, let me mark these two out. I use this one and I use this one. It's 5 halves. So that means I've got to go up by 5 halves. So you go 2 over 2, which is 1 there, plus 5 halves. So that equals 7 halves, which is 3.5. So the y value there would be 3.5. So in other words, I'm going up to this right here. So this would be your point, and that's a terrible color to use. But in this particular case, that would be, let's say, negative 1 for the x value. Again, just going over by 1 unit. And then we're going up by 5 halves. So that would put me at a y value of 7 halves. The next one, if you mark this one out, let me use a different color there. So let me use this color. You're going up by 7 halves. So now you have 7 halves, basically times 2. So let me cancel this with this and say that would be 7. So the next y value would be 7. Again, I'm going over 1. So now the x value would be 0. And I'm going up to a y value of 7. So here you get the 0 comma 7. Let's say this is x is equal to negative 4. Again, that's your axis of symmetry. This right here, the x value is negative 4. We're going to go right here where the x value is going to be 0. So we're going 1, 2, 3, 4 units to the right. So to go over here and get this point, I need to go 1, 2, 3, 4 units to the left. So that gets me that negative 8 comma 7. Similar thought process. I mean, if you wanted to do this one, so basically you're going 1, 2, 3 units to the right. So over here, you need to go 1, 2, 3 units to the left. So let's just say, I'm going to try to line that up as best as I can. Let's just say that's about right there. So this one would be negative 7 comma, and then we'll say 7 halves. Let me close that down, and maybe this arrow could be better there. And then for this one, we would go 1, 2 units to the right. So over here, 1, 2 units to the left. Again, so on and so forth. So just my closing thoughts on this. Again, if the coefficient for x squared is not an integer, it's probably better in most situations just to use graphing transformations. This is going to get really, really tedious really quickly. All right, for problem 6, we have f of x equals negative 1/2 x squared minus 3x minus 9 halves. So again, another example where the a value, or the coefficient for x squared, is not an integer. So this makes things a little bit harder to use the step pattern on. So we have something like f of x is equal to a times the quantity x minus h squared, and then plus k. Again, where a is equal to the coefficient of x squared, so that's negative 1/2. b is equal to the coefficient for x to the first power, so that's negative 3. h is equal to negative b over 2a. So b here is negative 3, so that's the negative of negative 3. And then the a here is negative 1/2. So 2 times negative 1/2 is negative 1. And so basically you have negative 3 over negative 1, which is 3. And so this would be the negative of 3, which is negative 3. Okay, let me get rid of this and put a negative 3. So k is equal to, you want f of h, which is negative 3. So let's come over here and say f of negative 3. This equals negative 1/2 times negative 3 squared. And then minus 3 times negative 3. And then minus, let me actually scooch this over so it fits. You have your 9/2. Okay, so negative 3 squared is 9. 9 times negative 1/2 is negative 9/2. Let's go plus negative here. Negative 3 times negative 3 is 9. So plus 9. And then you have minus 9/2. What I would do here is just say negative 9/2 minus 9/2. I'll do that first. So that would be negative 9 minus 9. That's negative 18. Over the common denominator of 2. And then you have plus 9. Well, negative 18 over 2 is negative 9. So you get negative 9 plus 9, which is 0. So k is equal to 0 here. And so this, you can just get rid of it. You can put plus 0 if you want. That's really up to you. We know that minus a negative is plus a positive. Let's just go ahead and write this as x plus 3 right now, quantity squared. And the a value is negative 1/2. Okay, so in this particular case, I would just use graphing transformations. It's going to be a lot more straightforward. But if you want to use the step pattern, I'll just show you both, just so it's crystal clear. Again, if you compare this to g of x is equal to x squared, what's happening is horizontally, you're shifting to the left by 3 units. Because again, on the inside, you want to undo things. So we're going to say we're going to shift left by 3 units. And then vertically, you're just going to break this up into 2 things. The negative gives you a reflection across the x-axis. It's a vertical reflection. And then multiplying by 1/2, again, you could say that's a vertical shrink by a factor of 1/2, or you could say it's a vertical compression by a factor of 2. Again, different terminology, same meaning. So vertical compression by a factor of 2. So if you had some x comma y that's on the graph of g of x equals x squared, when you get to f of x equals negative 1/2 times the quantity x plus 3 squared, it's going to be, again, shift left by 3 units, x minus 3. And then here, basically, you'd say that you're going to take your y and divide it by negative 2, or you can just say the negative of y over 2, something like that. So let's close that down. Okay, let's go ahead and grab this. Again, you can just note that the vertex is going to occur at negative 3 comma 0. Okay, let me paste this in right here. And let me also paste this right here. And I'm just going to label the graph like that. So we know the vertex occurs at negative 3 comma 0. Again, you can write that out if you want. Not necessary though. Basically just looking at those points that we know, again, you can go through this really quickly. So something like 0 comma 0, that's going to go to 0 minus 3 is negative 3. And then the negative of 0 is still 0. 0 divided by 2 is 0. So that's how we get the negative 3 comma 0. Again, the vertex for g of x equals x squared. The vertex for the f of x equals negative 1/2 times the quantity x plus 3 squared. Okay, when we think about the other points, think about where you're getting y values where you could divide by 2 and you still have an integer. Well, if you do the points negative 1 comma 1 or 1 comma 1, that's not going to work. So you'd want to go to negative 2 comma 4 and then 2 comma 4, that would work. So here, negative 2 minus 3, that's negative 5. And then the negative of 4 over 2, negative 4 over 2, that's just negative 2. So this right here, it would still be negative 2 for the y value. And then 2 minus 3, that's negative 1. So you're going to have this negative 5 comma negative 2, and then this negative 1 comma negative 2. So that's pretty straightforward. Let me get rid of these so I have some room. Again, if you go to the next one, which is negative 3 comma 9 or 3 comma 9, you're going to get a non-integer value when you think about y. So I would go to something like negative 4 comma 16, and then you have 4 comma 16. Again, it's going to be easier to work with. So negative 4 minus 3, that's going to give you negative 7. And then negative 16 over 2, that's going to be negative 8. And then here, 4 minus 3, that's 1. And again, this would just be negative 8. So that's how you get this negative 7 comma negative 8 and this 1 comma negative 8. So in this particular case, I think graphing transformations would be a better approach, a faster approach. But again, this is all personal preference. If you want to use the step pattern here, you can. It's just much, much more tedious. So you would start with your pattern. So you have the 1, comma 3, comma 5, comma 7, so on and so forth. You're going to take each number here and you're going to multiply by this negative 1/2. So that's your a value. So 1 times negative 1/2 is negative 1/2. Then 3 times negative 1/2 is negative 3/2. And you just continue. So then you'd have negative 5/2 and then negative 7/2. Again, so on and so forth. Let me move this down a little bit. Now let me get rid of this. This is what we're going to be working with. again, you're always moving 1 unit to the right. You start at the vertex. So we know the vertex is negative 3 comma 0. So if I'm moving 1 unit to the right, the point I'm going to generate would have an x value of negative 2. What about the y value? Well, you're looking at this right here. And in other words, if it's negative, you're going down. So if I have negative 1/2, well, I'm starting at 0 for a y value. I'm just going down by half of a unit. So 0 minus a half would be negative 1/2. So this is the point that I'm going to be at. So 1 unit to the right, half a unit down, that's going to be right there. Let me see if I can fit that in there. Actually, I should probably make that a little bit smaller. So maybe I'll do it like this. So this is negative 2 comma negative 1/2. Now, I'm going to do that again. I'm going to go 1 unit to the right. So now the x value is negative 1. And then my y value, well, right now it's negative 1/2. This right here is the next number in that pattern. So you're going to take that negative 1/2 and you're going to subtract away 3/2. So this becomes negative 1 minus 3. That's negative 4. And then over the common denominator of 2, negative 4 over 2, that's going to be negative 2. So the y value is negative 2. So close that down there. And you can see that we already have that point labeled. So 1 unit to the right, and then you're going to go down by 3/2. So that's going to put me right here. So I'm at that negative 1 comma negative 2. Okay, let's go to the next one. I'll just mark this one out. So now we're at negative 1 comma negative 2, 1 unit to the right. So that means the x value would be 0. And then the y value, now you've got to do negative 2, and then minus this 5/2 here. Get a common denominator. Let's write this as negative 4 over 2. And so negative 4 minus 5, that's negative 9, over the common denominator of 2. So that's negative 9/2. You could also write that as negative 4.5. So let's put 0 comma negative 9/2 there. And that's going to be, let me pick a good color here. Let's just say it's about right there. Not going to be perfect. Let's slide that over there. Actually, I can make this smaller. So let's say that this right here would be 0 comma negative 9/2. And again, let's just do one more of these. Let me mark this one out. Now you have negative 7/2. So 1 unit to the right. So now the x value would be 1. Let me just write this out. And the y value would be, you have this negative 9/2, and you're subtracting away 7/2 because you're going down by 7/2. So this would be equal to negative 9 minus 7, that's negative 16, over the common denominator of 2. So negative 16 over 2, that's going to be negative 8. Okay, so this would be 1 comma negative 8. And again, we already have that point right there. Okay, so once you have these points, again, you can just use your axis of symmetry. You would have x equals negative 3. Let me go ahead and sketch that in. So this is my x equals negative 3, my axis of symmetry. So again, if I have this point right here, and this labeling here is probably going to get in the way. So let me change that up. I'll just label it like that. So this point, which I'm going to draw in, let's say right here, you could get that by saying, okay, if I'm right here, my x value is negative 3, I would go 1 unit to the right to get to this point right here where the x value is negative 2. Well, if I'm here, I want to go 1 unit to the left to get this point right here. So that means that this point would be negative 4 comma negative 1/2. It has the same y value. So negative 4 comma negative 1/2. Okay, so coming to right here, let's say, and let me put a little dot there for clarity. I don't know if it shows up. Maybe I'll use a different color for that one, and I'll change to this color and put it there. So for this one, again, the x value is negative 3. I'm going to go 1, 2 units to the right to get there. So over here, I would go 1, 2 units to the left. So I get my negative 5 comma negative 2. Then coming down, it looks like we have this point right here. Let me try to line that up. It's not going to be perfect. Let's just say that's about right there. So I would go 1, 2, 3 units to the right to get here. And so I want to go 1, 2, 3 units to the left to get there. And that color does not show up so well. So let me redo that. So this would be negative 6 comma negative 9/2. So negative 6 comma negative 9/2 for that point right there. And then just coming down, let's do this one right here. So again, you would go 1, 2, 3, 4 units to the right to get to this 1 comma negative 8. And so I would match that and go 1, 2, 3, 4 units to the left to get to this negative 7 comma negative 8. So once again, I think that it's a lot more tedious when you have something that's not an integer here. And I would probably say that graphing transformations is a better approach in that scenario. All right, now let's change things up a little bit. So for the instructions, we're asked to find the equation of the parabola in vertex form. All right, so this is going to be for problem 7. And what we're given here is this graph, and we want to figure out the vertex form of this guy. So remember that is going to be f of x is equal to a times the quantity x minus h squared, and then plus k, where this vertex is going to occur, let me fix that, at h comma k. Well, we can see clearly the vertex is at 3 comma 0. So that's something we already know, so we can fill that in. The vertex, again, the h is 3 and the k is 0. So let me write this a little bit lower. We'll say f of x is equal to, I still don't know what a is, but I'll show you how to get that in a moment, times the quantity x minus your h is going to be 3. So this is squared for that quantity, and then plus your k is 0. Now you can leave off the plus 0. You don't need it. You can put it there if you want. It's not going to hurt anything, but I would just get rid of it. Now how do we figure out what a is? Well, what you're going to do is you're going to replace f of x with y, and then you're just going to pick a point that is not the vertex. So don't pick 3 comma 0. You can pick 4 comma 1, 5 comma 4, whatever else you want. Just don't pick the vertex. And you're going to plug in for x and plug in for y, and that will allow you to solve for a. In other words, if I pick something like, let's say 4 comma 1, I know that this is x and this is y. Well, I can replace the x here with a 4, and I can replace the y here with a 1, and so now I can solve for a. So this is going to be really quick. 4 minus 3 is 1, and then 1 squared is 1. So this would be a times 1, which is just a. So you end up with 1 equals a, or you could say a equals 1. Let me just flip this around and say a is equal to 1. So once you have that information, you're ready to write this guy in vertex form. So let's say that this graph is going to be f of x equals, your a is 1, so you can just get rid of that. So then you have your quantity x minus your h is 3, and this is going to be squared for the quantity. And then again, instead of putting plus 0, because your k is 0, you can just get rid of that. So you could really say this is f of x is equal to the quantity x minus 3 squared. All right, for problem 8. Again, we're given this graph, and we want to figure out what is the function here. So f of x equals a times the quantity x minus h squared plus k. So we want this in vertex form. So at this point, we know the vertex. That's going to be 4 comma negative 2. So let me just write here that we have f of x is equal to a times the quantity, x minus, again, the h value is 4. So this is quantity squared. And then plus the k value is negative 2. So instead of plus negative 2, let's just write minus 2. And again, if you want to figure out what a is, you're just going to plug in. Replace f of x with y first, and then pick a point that is not the vertex. So you can pick this one, or this one, this one, this one. Just don't pick the vertex. Let's just go with 6 comma 2. So we're going to plug that in. So for y, you're going to plug in a 2, and this equals a times the quantity. For x, you're going to plug in a 6. So 6 minus 4, quantity squared, then minus 2. Well, 6 minus 4 is 2, so you would get 2 is equal to a times, you would have 2 squared minus 2. 2 squared is 4. So this would end up being 4a minus 2 like that. Let's add 2 to both sides. This would cancel, and you would get 4a is equal to, 2 plus 2 is 4. So let's divide both sides by 4. This would cancel. You're going to get a is equal to 1. So let me erase this and put f of x here. We know that a is equal to 1, so you can just erase this here. So this guy right here is going to be f of x equals the quantity x minus 4 squared minus 2. All right, for problem 9. Now we're not given a graph. We're just told that the vertex occurs at negative 5 comma negative 5, and the point is negative 4 comma negative 7. So again, you could just use f of x is equal to a times the quantity x minus h squared plus k. Plug in for the vertex. So let me go ahead and just write this as y is equal to a times the quantity. X minus a negative 5, you could write x plus 5, again, quantity squared. And then plus negative 5, let's just write minus 5. And then just take this point right here and plug in. So this is the x and this is the y. So for y, you're plugging in a negative 7. And then for x, you're plugging in a negative 4. So what is negative 4 plus 5? That's positive 1. 1 squared is 1, so you can just get rid of this. So let's just go ahead and add 5 to both sides of the equation. This would cancel. And so you would end up with a is equal to negative 7 plus 5, that's negative 2. So a is equal to negative 2. Let me just write that right here. So a is equal to negative 2. And again, you can just fill this in. So f of x is equal to negative 2 times the quantity. Again, x minus a negative 5 is x plus 5. Again, this is quantity squared. And then you'd have your negative 5 for k. So let's go minus 5. So this would be your function in vertex form. F of x equals negative 2 times the quantity x plus 5 squared minus 5. All right, for problem 10, we're told that the vertex is negative 2 comma 1, and that a point on the parabola is 2 comma 7. Again, for this problem, I would just set up f of x is equal to a times the quantity x minus h squared. and then plus k. So I'm just going to keep this here. I'll just write underneath it. We'll say f of x is equal to, we don't know what a is, so this is times the quantity. You have x minus h squared. H here, again, is going to be -2. So you're getting that from the vertex. It's the x coordinate. So you have x minus a -2, so that's x plus 2, and this is quantity squared. Then plus, your k here is 1. So now we just have to solve for a, and to do that, you can erase f of x and just put y in its place. And you use the point that you're given. So this is 2, 7. This is your x. This is your y. So in the place of x, just plug in a 2. In the place of y, just plug in a 7. So you'd have 2 plus 2, which is 4. So this would be 4 squared, which would be 16. So let's write this as 16a right here. I'm just going to subtract 1 away from each side of the equation. So this would cancel. Let's say that we have 16a is equal to 7 minus 1 is 6. Let's go ahead and divide both sides of the equation by 16. And let's say that this would cancel with this. And so now you have a is equal to, well, if you think about 6 and 16, they're each going to be divisible by 2. So 6 divided by 2 is 3, and 16 divided by 2 is 8. So a here would be equal to 3/8. And let me come back and just paste that right there. And again, we can just fill this out. So for a, you want to put 3/8 there. For h, again, it's -2, but this is x minus a -2. So let's write that as x plus 2. So again, this is a quantity being squared. And then your plus k, again, k is 1. So here the vertex form would be f of x equals 3/8 times the quantity x plus 2 squared plus 1.